Assalamualaikum, my name is Nurul Akila binti Roslan. My number matric S81549. Today, our group will be presenting an article named Production of Parsley and Pennyroyal with an African catfish-based aquaponics partially fed with yellow mealworm. The study investigated the sustainability and productivity of African catfish-based aquaponics system in which 30% of conventional fish meal was replaced with yellow mealworm larvae. The sustainability challenges is global food and protein demand is increasing, creating pressure on conventional food and feed resources. From the graph, we can see that the global food demand is expected to strongly increase. Demand for animal source foods and for empty calories increase over proportionally. Increasing global demand for food and protein has driven interest in such as aquaponics, which integrates aquaculture and hydroponics to efficiently cycle nutrient, conserve water, and produce pesticide-free crops. Conventional aquaculture relies heavily on fish meal as a primary protein source, but its continued use is environmentally and economically unsustainable. The African catfish is selected due to high tolerance to environmental fluctuation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Shahmina binti Amirul Zat. My matric number is SL0CX7. For the methodology, we conduct 8-week experiment in a controller greenhouse in Portugal using 2 recirculation systems. We compare a control group feed with 100% fish meal against a test group where 30% of the feed was replaced with yellow mealworm. The system integrates African catfish, choosing their high stress tolerance with two edible plants, which is parsley and pennyroyals. Throughout the study, we monitor water quality daily with track plants grow weekly. Finally, we analyze key performance metrics including biomass production, mineral profiles, fish behavior, and a comprehensive carbon footprint calculation to evaluate the system overall sustainability.
ResearchGap, a previous study on insect-based feed mainly focused on fish growth in aquaculture. However, limited research has evaluated its effect on plant performance in aquaponic system. In particular, the impact of mealworms-based feed on plant growth, health, and mineral accumulation is still unclear. Therefore, this study addressed the lack of information on how insect-based diet affect both fish and plants in aquaponics. For significance of study, the study provides important insight into the use of mealworms as a sustainable fish feed in aquaponic system. Although the system reduced the carbon footprint, plant growth and health were negatively affected. The findings highlight the need to optimize insect-based feed for formulation to ensure sustainable aquaponics without compromising plants and productivity.
Water quality parameters remain within optimal and comparable range in both aquaponic systems, stating that the partial replacement of fish meal did not impair system stability. Number 2, the 30% mealworm diet reduced carbon footprint of the aquaponic system by approximately 27% compared with the 100% fish meal system. However, plants grow under the 30% mealworms regime exhibited significantly reduces biomass 1 to 75%, lower the roots and shoots, fewer leaves, and poorer greenness and health status. Mineral analysis showed that elevated chloride levels in plants grown under the insect-based diet, alongside the copper and manganese accumulation in roots, while micronutrients such as phosphorus, potassium, calcium, and iron remain comparable between treatments.
In this study, replacing 30% of fish meal with yellow mealworm significantly reduced the carbon footprint by 27%, while maintaining stable water quality and normal Africa catfish growth. However, plant performance, particularly parsley and paneroia, was reduced in the insect-based system. This plant show lower biomass, reduced greenness, and weaker healthy issue. This reduction was likely caused by mineral imbalance, especially chlorine accumulation originating from the mealworm feed. Excess chlorine may have induced abiotic stress, leading to chlorosis and limited plant growth. Overall, while insect-based feed shows strong potential for sustainable aquaponic system, carefully optimize of feed composition and crop selection is necessary to balance environment benefit with plant productivity.
My name is Saintifik and my metric number is S80236. I will explain about practical application and feature direction. This research looked into using of yellow mealworm as a patient substitute for fish meal in an aquaponic system with Africa catfish. By replacing 30% of the fish meal with insect, reduce the system carbon footprint by 27% while maintain water quality. However, plants grow under this system show lower growth and some mineral accumulation likely cause need stress. Feature work show focus on optimized insect-based feed to prevent mineral imbalance and support healthy plant development.
My name is Penulisan and my metric number is S80377. So, in the conclusion, the use of locally produced insect-based aquafeed in aquaponic system shows strong potential to reduce carbon footprint and support sustainable and circular food production. However, although nutrient levels were similar, plants grow with a 30% yellow mealworm diet show reduced growth and sign of abiotic stress. This is likely due to the accumulation of certain minerals such as chloride, manganese, and copper, which may cause cell toxicity. Therefore, further research is required to optimize insect-based aquafeed to ensure healthy plant growth without mineral imbalance. That's all from our group. Thank you.